The Dark Power of Aliens. A group of scientists studying the mysterious force called dark energy believe that alien life exists in other universes. The lab is a giant gas cloud south of constellation Aquarius. The images show the distribution of gases through dark matter halo, and the colors are set so that cold gas, mostly neutral hydrogen, appears red and hot gas appears white. Although we live in a solid universe of solid and impenetrable matter, composed of protons, neutrons, and electrons, we're surprised to learn that matter and the atoms that make it up represent only 4% of our world. The remaining 96% consists of some as yet unexplored forms of mass and energy, to which we have given names such as dark matter, dark energy, dark gravity, ghost particles, and other such exotic names. But what is dark matter? We call dark matter the matter that must exist in the universe to explain the motion of stars and galaxies, but which we cannot observe because it has no radiation. Dark matter is cold, hence it consists of particles with large mass and low kinetic energy. And since we can't see it, how do we know it exists? Although we cannot see dark matter, we can easily perceive its existence if we observe the motion of galaxies as a whole, the speed at which they are moving away in an ever-expanding universe. We immediately understand that there must be much more matter than we see. This matter plays a huge cosmological role because it can determine the future of the universe. That is, if this matter has a limiting value, maybe eventually it will stop the expansion of the universe and start contracting it. But right now the universe is accelerating its expansion. This means that there is a kind of dark energy which contributes to its expansion. Dark stars, dark matter, dark energy, dark cosmological age, these are what modern physics claims are the basic ingredients of the other invisible side of the universe. It's even considered certain that ordinary visible matter, that which makes up the Earth, the Moon, the stars, and our bodies, constitutes only a small part of the total mass of the universe, while the unfathomable dark matter and energy occupy the greater part of it. The best understood and best known example of dark matter is black holes. By studying black holes at the center of our galaxy and other galaxies, we can conclude that their masses are related to the types of masses of the corresponding galaxies. This suggests two things: either that a galaxy's black hole knows its structure, or that the galaxy knows the black hole's properties. Images and studies from Max Planck Institute show that the expansion of the universe in megaparsecs per hour. A parsec is a unit of distance measurement in astronomy, and it corresponds to 3.26 light years, or 30.9 trillion kilometers. A megaparsec is about 3.3 million light years. The universe is expanding at 71.9 plus minus 2.7 kilometers per second per megaparsec. Of course, in the video we see small parts of it. The color purple represents dark matter. But how is extraterrestrial life connected to dark energy? According to the relevant theory, our universe has a perfect amount of dark energy, which works against gravity and causes the universe to expand at an accelerated rate. And since our own world represents only 4% of the total dark energy, must have created other universes with worlds similar to ours. The theory of the multiverse first appeared in the 1980s, but it has been the cause of intense controversy among physicists. Critics such as David Gross, Paul Steinhardt, and Paul Davies have argued that the question of the multiverse is philosophical rather than scientific, and that the hypothesis about the multiverse is harmful and pseudoscientific. And now a team of physicists led by Professor Richard Bauer of the Institute of Computational Cosmology at the University of Durham in North England, using giant computer simulations, has managed to show that if other universes exist, then they are just as likely to host life as it is ours, or even more advanced life. Their findings were published in 2 related papers in the journal Monthly Notices of the Royal Astronomical Society. One paper is entitled The 3 Phases of Galaxy Formation, and the other has a title, The Impact of Dark Energy on Galaxy Formation. What does the future of our universe hold? In the simulations, the scientists discovered, in addition to the crucial role that dark energy plays in the formation of stars and galaxies, that universes with much more dark energy than our own can successfully form stars and worlds, but the same can happen with much less. The question, therefore, is, why does this particular amount of dark energy exist in our own universe? In a parallel universe, there may be another self of us with different capabilities, in which different things happen than to us here. I think we'll have to find out a new law of physics to explain the strange property of our universe, says Professor Bauer. Their simulations were created using the EAGLE, that is Evolution and Assembly of Galaxies and Their Environments program, one of the most realistic mapping programs of the observed universe. The widely accepted theory of the inflationary universe claims that our universe arose from a brief explosion that has been expanding rapidly ever since. This can mean 2 things. A, that the universe will continue to expand ad infinitum, and B, that in some part it creates different worlds. In this way, he creates multiple universes, in other words, located in other dimensions, hence parallel worlds or alternate realities, and not 1 but 2, but an endless series of universes like ours, filled with Earth-like planets, societies, and even people that look like us. This I've translated from a Greek article. Please leave your comments, and thank you for your support. Kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support, and that you find all my content so interesting. You'll find the Patreon account details in the description box below.